to hold that data in the memory, right? It has to hold the data. Only one guy has to process, right? His question was,
You're not writing. You're not putting it into memory. You're writing it to disk.
you have mapper running
Yeah.
and use it back to register,
Yes.
right? You're using page in the engine in the background. So page uses memory mapping, right?
You're using Tails.
Yeah. By default, we're using page as the execution engine in the background.
Oh, okay.
Yeah, that's why.
I mean, I knew we were for Hive, but I didn't know we were for MapReduce.
So I think job is almost done. Look at number of producers here.
Just have a faster system.
Number of producers should be done.
I'm old enough to grow
Much faster.
So listed all those.
Yeah, just one reduce.
So you're good at that source.
But yes, if it's not right.
Then with the cluster computing, and then it also had surgeons that tried to use distributed SQL. Back then, it kind of died out when the machines got bigger. It's just brought all that back to life. You're stealing all that again and bringing it in. That's what all the new innovation off this is grabbing from
Yeah, I'm
back
finding
there.
that. I'm finding that.
Yeah, as you build the doing on top of that, you need to know what's underneath. And all you're doing is looking how to exploit it for what you need to solve the problem.
And there are a lot of kids plans for the dump.
You can do it. You can.
A good way to do that.
They've been high-level language up.
And they've never, they haven't gone from like programming to Z to small mini computers.
Yeah.
When it's a small distributed NFX, you're trying to figure out performance. Or slow networks.
Your best bet is, yeah, if you have the skills to do all the debugging, all the testing to see your bottlenecks.
I'm sorry. I apologize.
You have those skills yourself. Like otherwise you're a slave for somebody else to do it.
Yeah, there's a yarn driver. I think the one to go through or something.
I remember what.
So basically, what do you have?
Okay.
You have main program. You have some
1.6.
kind of input parameters. Validation. Okay.
I raised that. I went from the RD program that we used
Here's the meat.
solve that problem. Going into a program.
One of the big framework available for you. Open source framework is given, right?
Stuff we can't
This is the method you want. If you want to write a map, you inherit maps. What is the job? Register, code, partitioner,
You missed the partitioner. Remember extending the partitioner?
Yeah.
That's where it showed you 0 through 9. Case statement, right?
Yeah.
I get that, but in this case, really, this is, it's into the SDK kind of thing, right? So what, how do you
All of this is make life simpler.
Java?
Do the import. Look at the import. Look at the import. It's all Argentine. That's the package.
There's a package, right?
It's not a third party.
It looks like you want to start up down.
Because you don't want any reviews, you don't want any of that.
Right? You get the Hadoop configuration, right? So basically what it does is, it goes into a system, gets the Hadoop configuration into the system. How the data is, how the data nodes are there, how it is spread, gets all concrete information, and starts. Then I put it, right?
To multiply how many floors you have.
Package, but can you show the external jobs that you have?
It's in your way approach. There's drive controls.
What library it is coming from?
Yeah, you see that? Or the Apache.
An analogy is
Open source. It's all there in GitHub.
the F-16 started
Say Apache, you get all the projects.
really good high performance.
Yeah, just download. And if you are familiar with the Maven build system,
And it slowed it down.
and you have dependencies, you should just come in. All you have to do is write the code.
Yeah, the source code is with you, right? So now you know what we're importing, right? right? So Hive does it behind the scene, generates the code, right?
Okay.
Hive.
Yeah.
But we can show you that code. We did this code to process the Java, right? The Java process, which is yarn context. How do you connect to the yarn context, right? We need a context to run through the yarn, right? It's all part of this code. So you have the source file, you see that, right? But Hive, when you do a Hive command, that also does the map reducer. But we can't see that code. It's part of the shell.
Yeah,
Right?
basically you
It's
want
built in.
very very custom handling of stuff.
Right.
So usually this is done by product development. So the companies who do some product on top of Hadoop, they get into very raw map reduce. Hive and Pig doesn't help them. It's not a data flow framework. So they are building a product. So that's what you do it for.
You get more control when you write in Java or Python. That's why we wanted to show you this, how to connect to the yarn. Yeah, that's one thing, writing Java, right? Then you're writing on the top of 14 words. So you need to compare the releases, versions. Very important. And that's a class test. Yeah, you have to work. So many things. And then the Spark comes into picture, right? They're all running on the same Hadoop distribution. We'll talk about that now.
So in a nutshell, whenever you get a request to run a yarn job, either to Hadoop, Hive, Pig, or a raw map reduce. So basically, a request goes to resource manager. Yarn is a resource manager, right? Then these are node manager. These are data nodes, and there is a daemon called node manager running on all the data nodes because they manage that particular node, right? The resource manager creates application master. Application master can sit anywhere at any time. So when you send a job, it creates application master that takes over and looks for containers. So Yarn gives application master all the information it needs. Okay, this is a container available in this node, go ahead and schedule your jobs, run your jobs. So until that job is done, this acts like an application master for all the jobs running. So part of the job is running on this one and this one until the job is done. The next job comes into picture, maybe the application master is sitting here, not here. So it's pretty much very flexible. So there are two jobs running. One application master can be here, one be here, and maybe here. So that's how Yarn does. Yarn does resource container. What is each container? Each container is nothing but a JVM. It's an independent siloed JVM in the data node. So that there are two containers, maybe there are two jobs running and they never step on each other. If this job fails, only that particular job is affected and the other jobs still run if it has all the resources available. So it's pretty much well managed container-based, JVM container-based scheduling engine, basically. So if you don't have enough resource, it goes back to the scheduler, Yarn scheduler. It waits for the resources. When the resource available, then it goes into action, assigning all these resources again to run application master, container, and everything. So in a
the
nutshell.
configuration of the JVMs and all, is you do it through your master?
Ambari. You can through Ambari also you can do it. You can give a heap space size and everything.
So application master is responsible for assigning containers that does the job?
Basically, keeps track and talking to the name node and Yarn. So this is the interface to name node for that job.
Even that is on the same server, that container, all the containers is being managed by.
Yeah. So basically, there is another application master maybe managing this container because this is another job and application master sitting in this node.
Oh,
Right? So this is one simple. It gets too complicated if I show that.
okay.
Yeah. Right? At any time, a job running has application master here or here or here. Then they are managing their resources. At the same time, talking to the nodes and name node and resource manager. So that's how it keeps track of all those things.
This is 2.0. Map is 2.0. We're not talking about 1.0. If you bring in 1.0, you will get confused. 1.0 is gone. Past. They re-architected this. This is 2.0. This works better. So application master will pull it in. Just pull it into the node manager. 1.0 doesn't work.
Is it possible you can show the scheduler in the scheduler?
The Yarn schedule is built in. The Yarn schedule, it takes care of itself because it knows what resources are available. So you don't have really control. It puts in the queue, when the resource available, it schedules it. So there's schedule internal. So So there is a separate scheduler for your jobs. Who's scheduler? That's different. That's which you control. You want to run your job daily, monthly, or weekly. That's different case. That's your cron job style, right? For MapReduce. But this is internal to Yarn because Yarn needs to know what resource available or what I can run at any given time. So it schedules itself when you submit the job. It goes into the queue if there's no resource available.
And the containers don't have to all be the same. So if you have boxes that have more memory,
Exactly. Yeah.
each container can have that and it'll advertise that. So if your scheduler needs a container that has more memory,
Yeah.
it'll select those ones.
You can spawn more containers.
Yes.
Do more, take on more responsibility.
Yeah, so they'll kind of utilize the resources how it can do best. This is one of the reasons why you normally, if you're a Hadoop shop, you don't want virtualization.
No, my
This
question
is
is,
your
I understood
virtualization.
that, but the example that he gave us here was you ran the Yarn demo job, right? So it spun off the JVM and it executed the thing.
It doesn't do it. It submits it to Yarn.
Yes.
You said something I think which is very
I don't do anything. I just create a job,
Job and
submit to the Hadoop cluster. And Hadoop cluster knows which is Yarn. It takes
So
over.
at that point, your process here, in your code, the process is sitting here, it's submitting to a different process,
Correct.
or it's handing it over to
Unless,
Hadoop.
if you're doing
Where
it
is
with
that?
Hadoop, shit, you won't very much. There's no benefit for virtualization or complication. Yeah, the containers will divide it up. Earlier, as I said, it's a way to make all of it happen.
Rather, my question is,
Yeah, yeah.
if you're
You submit it here.
If you're a data center, if you're a data center and you want to cater to performance that come up and down, that's a good use case. Right.
I guess it would make sense to virtualize or simulate. I'm a developer, so I'm gonna projects.
Sanjay, do you want to take it offline?
Yeah, here. Yeah.
So when are you posting the source code? It's available.
See here, waiting for the job state, so it's submitted. Wait for completion. So data cursor. What is the data cursor?
Yeah, I'm on one. It's my, but I'm gonna bring my other computer tomorrow to catch up. Even there, yeah.
You did a job and submit.
Yeah, I mean, like,
That's also important.
the standards need to go up.
I'm just curious.
He's ready to break for dinner.
So we break for dinner.